Okay, we are graphing quadratics today when a equals 1, meaning there's not a number in front of x squared. Essentially, what we're doing today is we're putting together 6.1 and 6.3, and we are going to do both of those things for a quadratic and then put them all on a graph together. So I told you guys the very first day of this unit that by the end of the unit, we would be able to graph an entire quadratic. Today is that day. So step 1 is to find your axis of symmetry and your vertex. This is exactly what we did in 6.1. We're going to do x equals negative b over 2a. That is our formula for finding our axis of symmetry always. I abbreviated axis of symmetry to AOS, just space. Once we figure out our x value, that is also the x value of our vertex. So we plug that in and solve for the y of our vertex. So we're going to move down to our first example, and we're going to do that on our first example. So first example we've got down here is x squared minus 6x plus 5. We're going to do negative b over 2a to find my axis of symmetry. So x equals negative b over 2a. I've got lines over here to write down my a, b, and c. My a value is in front of x squared. It is a 1. My b value is negative 6. And my c value is 5. Okay, plugging in my b and my a, it would be negative 6 over 2 times my a value, which is 2 times 1. A negative is positive, so that is positive 6 over 2. And 6 divided by 2 is 3. So my axis of symmetry is 3. Okay, I am going to go ahead and graph as I go. Our axis of symmetry is not a point on our graph, but it's more of a guideline for our graph. Draw a vertical dashed line at 3. And that is going to be the middle of where our graph ends up. All right, the next thing that we are going to do is we are going to plug in that 3 for x. So we are going to do 1 times x squared, so it's going to be 1 times 3 squared, minus 6 times 3 plus 5. 1 times 3 squared, minus 6 times 3 plus 5. You guys can throw that in your calculator. I just zoomed in, not to zoom back out. 1 times 3 squared, minus 6 times 3 plus 5, and I get negative 4. So I simply plugged in 3, put it in my calculator. Okay, because we are graphing as we go, we can go ahead and graph that point on our graph. So this means my vertex is at 3, negative 4. So on my graph, I just go over 3, to the right, down 4, put a dot there. Put a dot at 3, negative 4 on my graph. Any questions right now about axis of symmetry or vertex? Okay, so let's move back up to our little notes section and talk about the next thing that we need to do. So the next thing that we need to do is we need to factor to find our zeros. So we've got our table here, which tells us whether a number should be positive or negative. This is back from 5.6. I just copied and pasted the table, literally. Once we get it factored, we're going to set each factor equal to 0 and solve. So coming down to my problem down here, I've got x squared minus 6x plus 5. I'm going to actually rewrite it right here. We need to find two numbers that multiply together to be 5, add together to be negative 6. How can we multiply to be a positive? Two negatives. So we are going to do negative 1 and negative 5, because negative 1 times negative 5, positive 5. Negative 1 plus negative 5 is negative 6. So my factored form is going to be x minus 1 and x minus 5. Okay, from there, we are going to set each of those equal to 0 and solve. I'm not going to actually write it out because I know x minus 1 equals 0 when x equals positive 1, and I know x minus 5 equals 0 when x equals positive 5. So at this point, for the sake of time and the sake of space, you are more than welcome to just put down the opposites. So we do want to see your factored form and then put down the opposites. Okay. Once we find those zeros, any questions about finding them before I graph them? Okay. Once we find them, we can graph them. Our zeros are when x equals 0. They go on our x-axis. So we are going to put a dot here at 1. We're going to put a dot here at 5. Okay. Anything you guys notice about where those two zeros are? They're on the x-axis. They're on 0. In comparison to what we've already graphed, anything you notice? In comparison to that line, anything that you notice? They're an equal distance on either side. So that line is our axis of symmetry. In order for our graph to be symmetrical, it's going to have to be on both sides. So part of the symmetry is it being on both sides. Okay, we've got one more step. This is the one thing today that is new, that we have never done this before. And that is finding our y-intercept. To find our y-intercept, we plug in 0 for the x in our function. Once we plug in 0, I'm going to show you on this first one, but we will see it's always just going to be your c value is going to be your y-intercept. So if I come down here and I plug in 0 to my function, I would be doing 0 squared minus 6 times 0 plus 5. What is 0 squared? What's 6 times 0? So this is always going to be 0 plus or minus 0, and then whatever your c value is. So 0 minus 0 plus 5 is just 5. So my y-intercept is 5. Our y-intercept it's the same concept as an x-intercept, but it's on your y-axis. So this is my y-axis. My y-intercept gets graphed up here at 5. We have one last step, which is plot your points, which is also new. We've already plotted our axis of symmetry and vertex. We've already plotted our zeros. We plotted our y-intercept. The one thing we have left we need to do is mirror our y-intercept. So we told you guys that this dashed line was your axis of symmetry. So that means your graph is symmetrical around that. So we know if there's a point 1, 2, 3 to the left of there, there's also going to be a point 1, 2, 3 to the right. So we're going to mirror across this point so we have a nice little U shape. Once you get all those points marked, you can then connect them into a U shape, not a V shape. So once you get all 5 of those points, you connect it into a U shape. Okay. As you guys are going through your graphs today, everything should line up to make a U shape. So if you've got a vertex here and your zeros are over here, that means one of them's wrong, okay? So make sure things line up to make a U shape. It might be bigger or smaller, but it's always going to make a U. A parabola, have you? Okay. Any questions on this first one right now? It's a lot of steps, but the difficult steps you already know how to do. That's why we did 6.1 and 6.3 before we even started thinking about this. Okay, let's flip it over. We've got one more to do together, and then you guys will have a ton of time to work on your assignment. So x squared plus 4x minus 5. What is my a value? 1. What is my b value? What is my c value? Negative 5. 1, 4, and negative 5. Okay, my formula to find my axis of symmetry always is x equals negative b over 2a. Plugging in my b value and my a value, negative b is going to be negative 4. And then 2a on the bottom is going to be 2 times 1. Two times 1 is 2, so now I've got negative 4 over 2. And negative 4 divided by 2 is negative 2. So that means my axis of symmetry is negative 2. My axis of symmetry is always a vertical line. So this is going to be a vertical line at negative 2. I'm just going to put it in there as a dashed line. Okay. Once I find the x that is my axis of symmetry, that is also the x of my vertex. So I'm going to plug in negative 2 there. That can get plugged in for x in my original equation. So it's going to be 1 times negative 2 squared plus 4 times negative 2 minus 5. Okay, so 1 times negative 2 squared plus 4 times negative 2 minus 5. I get -9 as my y value of my vertex. So I can graph that at -2, -9. These graphs are 10 by 10, so you can use that to help you and be like, oh, I don't need to count to 9. I can just go 1 in because they're 10 by 10. Okay. Any questions about axis of symmetry and vertex on this one? Okay. So then we will factor to find our zeros. We are factoring x squared plus 4x minus 5. Which means we need to multiply to -5, and we need to add together to be 4. The only way to multiply to 5 is 1 and 5. And then I know one of them is going to need to be negative in order to multiply to -5. Because I want to add to be positive, I want the bigger one to be positive and the smaller one to be negative. So it's going to be x minus 1 and x plus 5. Okay. And then our zeros are going to be the opposite. So if I were to set x minus 1 equal to 0 and solve, and I can do this, I have space on this side. If you want to see to remember what we did x minus 1 equals 0. We added 1 to both sides and got x equals positive 1. For x plus 5 equals 0, we subtracted 5 from both sides. Got x equals -5. So my zeros are positive 1 and -5. This is completely optional, whether you actually write that out. I don't care. So we'll put our zeros on at -5 and positive 1. And again, if you notice, they're equidistant from that axis of symmetry. Okay. Any questions right now? Get this done in under 20 minutes. Okay, last thing then is our y-intercept. For our y-intercept, we're always plugging in 0 for x. So we'll be doing 0 squared, which is 0, plus 4 times 0, which is 0, minus 5. So 0 plus 0 minus 5 is just going to be -5. You want to put a note to yourself right here that this is always your c value. You can. And then we're going to graph that. So this y-intercept is negative, so it's down here. This y-intercept is also to the right of your axis of symmetry, so we'll reflect that to the left. So 2 to the right, and then we just go 2 to the left. Put that same dot 2 to the left at the same level. Okay. And then we connect all of this into a nice U shape. Okay. I'm going to go ahead and stop this video. Bye, video.